Alright, so we're doing trigonometric integrals using case 2. So the first example we're going to do today is the integral of sine of x to the fifth times cosine squared of x dx. We're going to end up solving this integral in 3 steps. But before we start with step 1, what we want to look at is our powers. And that's going to help us with our first step. So, the power in sine of x to the fifth is odd, whereas the power in cosine squared of x is even. The rules of trigonometric integrals is that we will save one function of our odd, or one of our odd functions. In that, step 1, we're going to end up saving a sine function, because that's the one that's odd. So what we end up with after saving that is the integral of sine of x to the fourth times cosine squared of x. And then we can't forget our saved sine function, which is sine of x dx. We always want to put our saved function next to dx. Always. There are no exceptions. So we end up with this. So now step 2 is to use our identity function of sine. So we can use a sine identity. So we know that sine squared of x is equal to, or is the same as, 1 minus cosine squared of x. So now we're going to rewrite our integral using the identity that we just found. So I'm going to come over here, and we end up with the integral of, this is sine to the fourth, but we only know the identity for sine squared. So what we're going to end up with is 1 minus cosine squared of x squared, because that's going to give us sine squared squared, which is sine to the fourth. And then we have cosine squared of x and sine of x dx. So now our next step, moving on to step 3, is to use substitution in order to complete our solving of this integral. So we're going to let u be equal to cosine of x, which means that du is going to be equal to negative sine of x. Well, if we look at our integral, we don't have a negative sine of x, so we want to, dx, sorry about that. So we want to make this look like something up here. So what we're going to do is we're going to move this negative sign over. We're going to have negative du is equal to sine of x dx, which we do have up here. So now we're going to factor our variables back in. We're going to end up with the integral of 1 minus cosine squared of x. We only have cosine of x here, so it's going to end up being u squared, can't forget our other squared here, times cosine squared of x, so that's going to be u squared. And then sine of x dx we have here is negative du. Well, our negative sign is pretty much the same thing as a -1 coefficient. So we already know we can move that on the other side of our integral sign. So we end up with negative 1 times the integral of 1 minus u squared times u squared. And so now our next step is to expand. I'm going to actually move over here. In order to expand our function, we end up with negative times the integral of 1 minus 2u squared minus, or plus, u to the 4th times u squared du. Sorry, but I'm a du over here. And then now we're going to make things even easier. We're going to distribute this u squared, and it was negative times the integral of u squared minus 2u to the 4th plus u to the 6th du. And then we're going to use our basic knowledge of antiderivatives and find the integral of this. It's going to be negative times u cubed over 3 minus 2u to the 5th over 5 plus u to the 7th power over 7. And this is an indefinite integral, so we can't forget to add c on the back. And we can't stop here, we have to keep going. So that's going to end up giving us negative 1/3 u cubed plus 2 over 5 times u to the 5th minus, because we're distributing our negative sign here, minus 1 over 7 u to the 7th power plus c. And now that we have expanded this all out, we can put back in our u, which we found over here, which is cosine of x. So our final answer is negative 1/3 times cosine of x cubed plus 2 over 5 times cosine of x to the 5th power minus 1 over 7 times cosine of x to the 7th power plus 6. And this is going to be our final answer.